Okay, so today we have overlapping triangles, which is in 4.4 in your books if you want to follow along. And you only have one objective today. No definitions, no theorems, no postulates, just using overlapping triangles and proofs. And by the end of this, hopefully you'll be able to do that. If not, then that's what class time's for, to get that extra help that you need. So, since there's no theorems, definitions, postulates, or anything like that, we're just going to kind of get right into a proof and show you how to use it, and then do one that's a little bit more difficult, but we'll walk you through it. So, moving right along, we've got the following. We are given that segment DB is congruent to segment AC, and that segment AD is congruent to segment BC, and we need to prove that angle D is congruent to angle C. Now, your first instinct might be, it might not, but it might be to try and prove that ADE and BCE are congruent, and then you could go ahead and say that angle D and angle C are congruent by CPCTC. Problem with that is, if you went ahead and tried to prove that, you would find that you didn't have enough information to prove those two triangles are congruent. You could prove that DEA and CEB are congruent by vertical angles being congruent. And then you would have that segment AD is congruent to segment BC. But unfortunately, that's about all you could prove. So if you look closely, you'll see that you have two overlapping triangles that might be able to help you out. Now, what I like to do, because sometimes even I have a hard time seeing it, and especially when you get into the harder ones, where there's lines and segments all over the place, it's just easier for me if I go ahead and I try to use a highlighter or a colored pencil, something like that, where I can say, kind of separate out the triangles. So I'm going to say, well, I've got triangle BAC, or whatever three-letter combination you want to use. And I also have triangle ABD. So I've got these two triangles that I can see a little bit more clearly now, and kind of help me get through this problem without too much confusion. So let's go ahead and start our proof. So always start with your given. We're given that segment DB is congruent to segment AC. Can't do a whole lot else with that right now, so let's move on to our next given. We've got segment AD is congruent to segment BC, and the reason is it's given. So we've got two sides, and when you have two sides, you can either prove triangles are congruent by side angle side or side side side. Now, since we're trying to prove that angle D and angle C are congruent, and that would be what we would need to prove these two triangles congruent by side angle side, that's not going to work. So if you go down and you take a look and say, well, they both share segment AB. And I know I can do something with that because AB is congruent to AB by the reflexive property. So now I've got these three sides that are congruent, and I can say that triangle ADB and triangle BCA are congruent because of side, 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 as shown in steps 1, 2, and 3. Now that I have those two triangles are congruent, I can go ahead and say that angle D is congruent to angle C by CPCTC. Now, the one thing, and I've mentioned it before, I just want to make sure that we're all understanding it and on the same page here. You cannot use CPCTC until you've proven triangles are congruent by either side, 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 angle, side, angle, or side, angle, side. Those are the only three you know for right now, so focus on that before you use CPCTC. Okay? So remember, prove the triangle congruence first, and then you can go ahead and use it. So that's actually a fairly easy and straightforward one. Let's move on to one that's a little bit more difficult, a little bit more confusing. Don't worry, I'll walk you through the steps. Okay, now we're given that angle 1 is complementary to angle 2, that angle 3 is complementary to angle 4, and that angle 1 is congruent to angle 3. Now, if you look closely at this picture, this diagram, we have a whole bunch of overlapping triangles. Okay, we've got, looks like 4 pairs of triangles that are overlapping. So now it could get confusing and say, okay, well, which one do I use? Well, I've got this pair here, BDC and CAD, and it's got all the givens are down in that area, so I'm going to go with them. If you pick the wrong one, you would find yourself getting stuck, and then you just go back and choose a couple more. But for now, again, with all these lines, it's easy to get confused. So go ahead and highlight or do whatever you need to do to see the two different triangles. Alright, so let's go ahead and try and go through this step by step. Now, if you'd like, go ahead and pause it, see if you can figure it out on your own, and then come back and compare your steps to what I have and see if they match up. Now, I will preface this by saying that I get to a point in here where I prove it one way, but you could use another method. And I'll just explain it briefly, and I can show you that if you like tomorrow. But it's actually fairly straightforward. So let's go ahead and just get into the proof. So our first statement is that angle 1 is complementary to angle 2. That's a given. Second statement is that angle 3 is complementary to angle 4. Also a given. And lastly, that angle 1 is congruent to angle 3, which is a given. So we've got these three, and by themselves we really can't do a whole lot with it. However, if you think back a few chapters, we can say that angle 2 is congruent to angle 4. And that's because that angles that are complementary to congruent angles are also congruent. So now we've got angle 2 and angle 4 that are congruent. So that's a help. I can also say that segment BC is congruent to segment BC because of the reflexive property. So now I've got an angle and a side from each triangle. So that leaves me two options, angle side angle or side angle side. And again, if you look at what you're trying to prove, what you would need to prove side angle side is what you're actually trying to prove. So that's not going to work. That's your first clue about that. So that means that I'm going to have to go angle side angle. And here's where you kind of have a couple options. What I chose to do, just because I like bringing up old proofs as a reminder, we could say that angle ABC and angle DCB are right angles because complementary angles form right angles. And then we could say that angle ABC is congruent to angle DCB because right angles are congruent. Now you also could have said that angle ABC is congruent to angle DCB because of the addition property, because if you add congruent parts of congruent angles and add them together, then those new sums are congruent as well. For me, this is a little bit cleaner though. Now that I have that, I can prove that triangle ABC is congruent to triangle DCB by angle side angle as shown in steps 4, 5, and 7. And lastly, brings us to segment AB is congruent to segment CD by CPCTC. So, again, that's a long proof there. And the hardest part, I would think, would be to figure out which triangles to use and then to not get confused in the whole mess, which is why I suggest using, colors or pen and pencil, whatever it takes for you. Whatever is going to help you see it and be less confusing for you. And it's going to take practice. You're not going to get it on the first try. Well, you might, but you might not. And if you don't, it's not a big deal. That's what the class time's for, to kind of train yourself to think like that. It takes a little while sometimes. So don't get discouraged. Hang in there. We'll get through it together. As always, if you have any questions, please ask. Okay? So anyway, we will be doing a few different activities to kind of help hone that skill of yours, and you should be good to go by the end of the day tomorrow. Okay? So have a great night and be prepared for class tomorrow. If you have questions about anything that was covered in this video, write it down, come into class with those questions, and I will be happy to answer them. Okay? Have a great day, great evening, whatever it is. Thank you.